This is section 5.4, solving systems using linear combinations, or I like to call it elimination. So solving using linear combinations, there's a whole bunch of steps here. Basically what your end goal is to eliminate one of the variables so that, or in some cases there's going to be 3 variables, so in those cases eliminate 2 variables. But if you can eliminate some variables and get down to 1 variable, just like we did with substitution, once you're down to 1 variable, then you can just solve the equation, find your answer, plug it back in, and then if there's another one that you got to do, take that one and plug both of them back in to find the third missing variable if there is one. But there's a whole bunch of steps here. I would write those in your notes. So you got them. The first thing you want to make sure you always do on these is make sure that you're in like a form where everything matches up with each other, or everything kind of like aligns. Typically what the book does is they'll put it in standard form where you've got your like x plus or minus in there, y equals, and then whatever your constant is over there. If your 2 equations aren't set up like that, where like your x's are stacked, your y's are stacked, your equals are stacked, you'll want to rearrange stuff so everything is stacked up. Okay, so let's look at the first example here. So using our linear combination method, or like I said, elimination, we're going to solve this out. What you're always looking for with elimination, after we see that they're stacked up, so like here our x's are stacked, our y's are stacked, the equals are stacked, we're looking for opposites. And what I mean by opposites is like things that we can add together that would cancel each other out. So like in this case, I'm going to go with like 12 and negative 12. So here I'm doing that because if I took this negative 6 times 2, negative 6 times 2 is negative 12. So then negative 12 plus positive 12 will end up canceling out. So I'm going to take this whole top equation here times 2. Okay, and then it's just like distributive property. You would distribute that 2 to everything that's there, so it would be like 2 times 5 would be 10x. 2 times the negative 6y would need negative 12y or minus 12y, and then the 2 times the 3 would be 6. So what that does for us is that makes that negative 12y, and then if I put this other equation below it, so the 2x plus 12y is equal to 12, what you can then do is turn this into like a big addition problem. And then your 12s are going to cancel each other out because they're opposites. And then you would just add up the rest of your stuff here. So like 10x and 2x is 12x. 6 and 12 would be 18. And now because those y's went away, now we're down to an equation with just an x. And we can solve it when we're down to just one variable like that. So then to get rid of multiply by 12, we just divide by 12 on each side. 12s are gone. X would equal 18 divided by 12 would be 1.5. So that would be one of our answers. Then you just take that x once you find it and you plug back into one of the top equations. It doesn't matter which one you plug into, you'll both kick out the same y. I'm just going to plug into the top one there, so I'm going to go 5. And then instead of the x, I'm going to put in what I just found for x, so 1.5 minus 6y is equal to 3, and then now I can solve that equation out. So I can go 5 times 1.5, which is 7.5, minus 6y is equal to 3, and then I'm going to subtract 7.5 from each side, so I'll have negative 6y is equal to negative 4.5, and then I'm going to divide by a negative 6 on each side, so then my y will end up being 0.75. And just like when we did substitution, this is similar to like if we graphed it. So if we did take both of those lines and graph them on our calculators, this would be our crossing point. So like the ordered pair would be like 1.5, 0.75. So that would be the solution to that system. Okay, try another one here. So again, we're looking for opposites. And again, neither of this pieces that we have there are opposites, so we're going to want to do some multiplying here. I think I'm going to go and I'm going to try to get rid of the x's. You could also try to get rid of the y's. It doesn't really matter. I'm just going to go with the x's. So what I'm going to do is I'm going to get them to the same number or opposite numbers. So I'm going to take this top one here times 5. And I'm going to take the bottom one times negative 7. Okay, so then 35 and negative 35 will be my x values, and those should cancel. So I'm going to take this whole top one times 5. So that would be end up being 35x minus 15y is equal to negative 45. And then I'm going to take that whole bottom one there and distribute the negative 7 to all of those. So that would be negative 35x. And then it would switch to plus 28y is equal to, and then negative 7 times negative 25 would be a positive 175. And then now I turn that into my big addition problem. And the whole purpose of all that multiplying was to make those opposites, because now those will cancel each other out when we add. And then we'll combine the negative 15 and the positive 28, which would be 13y is equal to, and then we'll go 145, or negative 45 plus 175, which would be 130. And then divide by 13 on each side. Those are gone. So y would equal 130 divided by 13 is 10. And then same as before, you'll just want to take that value you just found, plug her back into one of the top ones. Again, it doesn't matter. I'm just going to go first one there, so 7y minus 3, and then instead, or 7x, sorry, minus 3, and then instead of the y, I'm going to put the 10 in there. It's equal to negative 9. So that would be 7x minus 30 is equal to negative 9, and then add 30 to each side. So it's gone, so 7x is equal to 21. Divide by 7. X should be equal to 3. And then again, if you want to write those as the ordered pairs, it could be 3 and 10 as your ordered pair of the spot where they would cross. But it doesn't say you have to write them as ordered pairs, so I take those as well. Okay, next example here. We got an activity that's on page 322 in your books. So I'll flip her up here. It'll be right there. So we got long distance runner, Mary something wants to get 800 calories and 50 grams of protein for a dinner course of chicken and pasta with sauce. Protein and calories count for each item, or protein and calorie counts for each item are given below. How many ounces of each type of food does Mary need to eat? Work with a partner, obviously not, we're not going to do that, we're just going to solve it out here. Okay, so they give us the information in a table here. So we got chicken, we got pasta with the sauce, and then they've got it split out into protein values and calorie values, and then they give the totals that we need there, and we're supposed to figure out how much we need of each of these things. Okay, so when we set this up here, we're going to have our system of equations again. Do our curly bracket there. We're going to want two different equations here. We're going to want one for the protein and one for the calories. So let's make our C equal to chicken and our P equal to pasta. And pasta with sauce, I guess. Okay, so we got one there for our protein information. So protein for chicken is 9. So I'm going to go 9C. Plus our protein for the pasta with the sauce is 2. So 2P with the pasta. And then our goal for amount of protein is 50. So that takes care of our protein stuff. And then our calories, we're going to have 65 calories for the chicken. So 65C. Plus we got 45 calories for the pasta sauce. So 45P. Is equal to our goal for total calories is 800. Okay, so we got our system there, and then after we get it set up, then they just walk through some different steps, but basically they just want us to solve it out. So we're going to take that and solve it then. So looking here, we don't really have opposites of either, so we could probably just take either one of those and try to eliminate. I think I'm going to go with the P and try to get rid of that one. So I think I'm going to take my top equation there times 45. And my bottom equation, I'm going to take that all times 2. Or I should probably make that a negative 2 to make them opposites. And then that should cancel some stuff out here. So I'll probably get some pretty big numbers when I do this. So 45 times 9 should be 105 C, plus 2 times the 45 would be 90. P is equal to, and then 45 times 50 would be 2,250. And then I'm going to do the same thing with my negative 2, distribute that through. So negative 2 times 65 would be negative 130 C, plus, and then I'm going to go negative 2 times the 45, so really it would be like minus or negative 90p, either way. And then the negative 2 times the 800 would be negative 1600. And then again, our goal was to get opposites there, which now we have because we got 90 and negative 90. So I'm going to do my big addition problem here. Those guys are going to cancel out. And then I'm going to do my 405C minus my 130C, which is 275C. It's equal to, and then I'm going to add those guys together, 2,250 minus 1,600, which is 650. And then divide by 275 on each side. That'd be gone. So our C would equal, and I don't think this one comes out nice, 650 divided by 275. Yeah, it doesn't come out nice. So we can go like approximately, I'll switch this to the approximately symbol, approximately let's just go 2.4. So 2.4 of our chicken. And then again, same as what we were doing before, we take the value we just found, take her back up to one of the top equations and plug her in. I'm going to go with the 9C one, so I'm going to go 9. And then instead of the C, I'm going to go with that 2.4, approximately 2.4 that we just found, plus 2P is equal to 50. And realistically, I didn't mention this before, but you could also, if you wanted to, plug into either of those equations as well. I typically don't do those ones because usually it's bigger numbers, but it really doesn't matter. You could take that 2.4, plug it into either of those, and also still get the same answer. But here I'm just going to go with this one. So I'm going to go 9 times 2.4s, 21.6, plus 2P is equal to 50. And then I'm going to subtract 21.6 from each side. So that's gone. So I'll have 2P is equal to, should be 28.4. And then last step, divide by 2. So P would be equal to, technically it is approximately equal to, since we rounded on that one, it's approximately equal to. And this will come out nice when you divide it. It'd be 14.2 for our pasta with sauce. But again, it's approximately equal to, because technically that one was approximately. But that would be our two values for that one. Okay, now our last one here, this is where it gets a little bit tricky, because instead of just having 2 equations, they switch it to 3 equations, and then there's 3 variables we have to solve here, which makes it a little bit more complex, okay? And the steps for doing this are on the front here, so same as what we did before, looking to eliminate one of the variables. If we can do that, then we can get down to an equation with 2 variables, and then we use that one to do some more eliminating, and once we get down to like 1 variable in our equation, just like these other ones, solve that guy, then start doing your plugging in. Okay, so here we got 5x plus y plus 6z is equal to 3, x minus y plus 10z is equal to 9, and then 5x plus y minus 2z is equal to negative 9. So my first reaction thought here is, if I look here, all of my y's are kind of similar-ish to each other because they're all 1s there. Here we've got a plus y and a minus y and then a plus y there. So I would be kind of thinking that maybe the y's would be a nice thing to go away. And usually there's one, they set it up in the math books, usually where one of them seems like it might be an easier one to get rid of. And I'm thinking in this case it's probably those y's because they're already similar numbers. They might not make it as obvious in some of the problems, but usually in these cases, they try to make it not so complicated like some of the other ones with like super big numbers. But I'm thinking that maybe we try to get rid of the y here, and I'm thinking maybe we group, I'm going to use some colors here, I'm thinking we group those two together and get rid of the y, and then, I'll use green here, I'm thinking we also group those two together because that'll also get rid of a y. Okay, so what I'm going to do is I'm going to take those top two and I'm going to get rid of that stuff first. So I'm going to go 5x plus y plus 6z is equal to 3. And I'm going to combine that with my one that's x minus y plus 10z is equal to 9. Okay, so everything's lined up, so I'm good to go there. And then also, like I said, what's nice about this is those guys are already opposites, so I don't even have to multiply by anything. They can automatically just cancel out. So then I'm just going to combine these guys, so 5x and that would be like 1x, be 6x, 6z and 10z would be plus 16z is equal to, and then 3 plus 9 is 12. Okay, so that got rid of one variable for us. Now I'm going to do the same exact thing with the second two here, and I'm going to try to get rid of the y with those, so then I can take this equation, and then I'm going to do it over here, my new equation when I got rid of y, and then it should be x and z, and my other one should also be x and z. So now I'm going to do this in a different color here just to kind of show you. So I'm going to take this second one and the third one and combine those. So I'm going to go x minus y plus 10z is equal to 9. And I'm going to combine that with the other bottom one there. So I'm going to go 5z plus y minus 2z is equal to negative 9. And again, we picked those because our y's would easily cancel out there. So then we've got, again, that'll be like a 1. So 1 plus 5x would be 6x. And then the y's are gone. 10z plus negative 2z would be plus 8z. Is equal to, and then 9 and a negative 9 would make that 0. So then now, switch to another color here. Now I'm going to combine this guy and this guy because those are both down to x and z. X and z, very similar to what I had when it was just the ones with two variables. So now I'm going to take those two guys, and I'm switching to a third color here. I'm going to put those guys together. So I'm going to go, okay, I got 6x plus 16z is equal to 12. And then I've got 6x plus 8z is equal to 0. And then I'm going to have an issue with this one because I don't have opposites, but I'm pretty darn close to opposites with my 6's. Let's see if I got another color here. I'll switch to blue. So I got another combination I can get rid of here is the 6's, but I'm going to have to make one of them negative to make them go away. So say I make this bottom one here times a negative 1. Should put my system symbol there. So if I take that negative 1 times that stuff, now that equation, switch back to the purple here, now that equation is going to be, rewrite my top one, 6x plus 16z is equal to 12. And the order doesn't really matter. I don't know, kept it on the top. This bottom one's where I'm going to do the distributing. So I'm going to go negative 6x, take the negative to the 8, so that'd be negative 8z or minus 8z either way. And then the negative times the 0 would still be 0. And now we're to the point where now those 6's can go away from each other. And we'll be down to 16z minus 8z. That would make that 8z is equal to 12 plus 0 would just be 12. And then now we're down to just one letter, just like we were with the previous ones. So divide by 8 goes away. Z would be equal to 12 divided by 8 would be 1.5. So that gives us one answer. Now that we've got that one, now we can use that to find our other two. So here we know our z is 1.5. So to be able to find that, what I would do is I would take this z and either plug it into that one there or that one there, because those just have two variables. So if I put 1.5 into either of those, that'll help me find my x value. Then once I have my x and my z, I can plug back into one of my originals to find my y. So now I'm going to go, I don't know, probably doesn't matter. Let's go this one. So I'm going to go 6x plus 16, and then instead of my z, I'm putting that 1.5 in there. Is equal to 12, so that'd be 6x, 16 times 1.5 would be oh, what would it be? 16 plus 8 would be 24 is equal to 12. And then subtract 24 from each side. So that would be 6x is equal to, and that would be negative 12. And then divide by 6. Divide by 6. X is equal to negative 2. So then that gives me that one. Now I can take those two that I just found. So I already had my z, just got my x. So now I can take that one, put it back up into one of the originals, and that one, put it back up into one of the originals to then find my last value there, the y. Kind of running out of colors here, so I'll just do this one in black again. So again, it doesn't matter which one you plug into. I'll just go with the first one there. So 5, and then instead of the x, we're putting in that negative 2, plus y, plus 6, and then instead of the z, we're putting 1.5 in. It's equal to 3. So then 5 times negative 2, negative 10, plus y, plus 6 times 1.5 would be 9. Is equal to 3. Negative 10 plus 9 would be negative 1. So y minus 1 or plus a negative 1 is equal to 3. And then add 1 to each side. Y should equal 4. So those ones are kind of a lot going on with those. Well, like I said, kind of work it in steps. Try to figure out which variable is going to go away the easiest first. Get rid of that guy, and then once you get down to 2 equations, then just work it like our previous ones. Find one of the letters, and then do all your plugging in. And the color seems to help me to kind of keep stuff organized, but again, you kind of need a lot of colors there, and it gets kind of messy. But just kind of work your way through those the best that you can. Okay, so that's it for this section. So your notes, it doesn't give a page there, so that's not helpful. Should be, it looks like it's page 325 in the book. So 325, 1 to 16, and then skip number 15.